Hopefully it should be up now. It's still not showing. But that's okay. Maybe it'll show up soon, so I can actually put something I need to actually... Alright, there we go. Something I need to actually... yeah, I'm gonna put the Discord, and I'm gonna put the project link. Let's grab that project link here. Alright, that should be good. Yo, what's up, Ghost? I think I saw you there for a second. Pick up the chat. Alright. I got the chat up where I can see everything now. Alright, what's up, Ghost? I'm doing pretty good. How about you, man? How's the language going? Hey, that wasn't even planned, X, so that just happened. That just happened just like that. I didn't even know, but it just happened on 10:30 exactly. Yeah, been pretty good, Ghost. How's that language going? What was the language called again? Like lead, I think, right? I think. Okay. Yesterday we were writing the visitor pattern for each one. I appreciate it, Exo. I appreciate it. Good looking out. Good looking out. The lecture's not too hard, just trying to add ints. It is called that. Yeah. Yeah, ints shouldn't be too difficult. I made a short about it, about how I parsed it. Not parse, but lex through the ints. Alright, where did we leave off? Like, exactly, let me see. So, visitor.age, we set up all the functions within there, the expression visitor and statement visitor. And we also did... Right, we had a whole difficulty with the includes and stuff, so yeah. Yeah, so we need to have this pattern for every single one then. Yeah, that makes sense. Yeah, okay, let's try and do that for every single one. So I'm just gonna say for each one, I'm gonna... Okay, let's just copy this. It's gonna be relatively similar. So let's say void binary node, and this will be for the unary op node. So we're gonna change that. Unary op node, accept, and we need it to be, yeah, expression visitor reference, but instead we're visiting unary op. I can't wait to get done with this visitor pattern, bro. This visitor pattern has been like a thorn in my back, bro. Whatever they say, whatever that saying is goes. A thorn in my side. Okay, yeah, so except we need to actually implement the function within the header file itself, and that's for the ast.h. So we basically just need to copy this over and set that in. So for the unary op node, we have the visitor function for declaration. And as I found out yesterday, override only goes within the header. So we don't need to actually call override here. You can handle ints, but it is hard trying to put it in switch case. I have add, string, and floats. You can actually make floats and integers in the same function. You don't have to make separate functions for ints. Let me show you how I did that. So for mine, so there's like a general case for when it hits a character token here. So if the character ends up being a digit, it calls a number function, and within the number function is where the logic happens. So if you have a digit, you keep advancing, and then you can handle decimals also here. So if it hits a decimal and the next number after the decimal is a digit, we keep advancing. We advance, okay, no, this first advance is to advance to a decimal, and then we advance for each subsequent digit after that until we hit a non-digit. And then essentially grab that substring wherever it is in the file, your source string file, and then you add that token. And you can just add it as a number literal. Okay, how do you know, how did you do the advance? So the advance, basically, it should just consume a token forward, or consume a character forward. So yeah, basically returning the part in the source that we're in, the current source string, we return the current char value that we're at, and then we advance forward. So let me give an example. Let's say we're having a number like 1234. We're on this character and we're just returning that character, but we're also advancing. In code, under the hood, it would kind of be like, let me kind of write it out. Under the hood, it would be temp equals current plus current, so we're going forward by one character forward, and then we're returning the temp value. So with each character, we're advancing forward and returning the character that we're currently on. That's how I did it. I don't know if Rust has like post increment and pre-increment like differences like that. I guess you don't really need to do the post increment. You can find a different way to implement that. But yeah, I just did the post increment like that. And your second question, how do you know if it's an int? Using the isDigit helper function here. Basically, you implement it within ASCII if the char is greater than or equal to 0, less than or equal to 9. Because in the ASCII chart, it should be ASCII code. Let me go to the website. It's right here. They're subsequent. They're like all together. So 1 through 9 are all together. Where is it? What? Oh, I skipped it. Yeah, here. 0 through 9 are all together from 48 to 57. Yeah, so that's the best way to check it. Same thing for identifiers. You just need to implement isAlpha and isAlphanumeric to get the values. So yeah, that should be the way you do that. You did the same thing? Yeah, that's perfect. That's perfect. Okay, expression visit. Yeah, okay, what am I doing? Yeah. So essentially just the same thing for every single one, as we know. Let's just try and get this going quick. So after unary is literal node. Is it called visit literal node? Okay, yeah. It's called visit literal node. Let's do the other ones too. Identifier and function call. So identifier node, and also function call. So func call and their respective stuff. So visit call node, I believe, and I mean, I guess I should probably keep it same. If I called all these node and I didn't call these node, it might be a problem. So let's just call these nodes. So node, node. Identifier node. And then implementing each of these functions within their respective file, respective struct. So for the literal, we're going to have that. Override. Okay. What is going on though? Func call node. Oh, yeah. Semicolon. Okay. Yeah, looks like everything is being taken in now. Yeah, that's for the main ones. Now we also do need it for the regular statement itself. So let's see. Statement. I mean, I guess they're just gonna be the same. Just basically the same, right? So we can kind of just set it the same way. So void. So I'm just gonna move it. So let's call it void. Where is it? Okay, let's do the first one. Var double statement. Accept, and then we grab a function there. And we're gonna visit what is it called in here? Visit var decal. Okay, just call it decal. When we finish our languages, we should see which is faster. It sounds like a good plan though, not gonna lie. It sounds like a good plan. Is it var decal? But yeah, we need to. Okay, there is something that we need to do. Yeah, the struct for statement visitor needs to be for declared. We had that problem yesterday. I remembered. I will never forget again. Hopefully. Mine's probably gonna be slow for a while, to be honest. Okay, so we have a struct for declared. Man, I really want to get to the parsing, bro. I want to get to the parsing, so I want to finish this fast. Because the parsing is actually the interesting stuff, so yeah. We need to implement each of these except functions, so basically the same in there. We can just literally grab it from here, it should be the same. But we do need to actually implement the function in here first, but it's going to be a virtual void here, so we can actually allow polymorphism, and it's not going to be override, so it's going to be accept, taking the same parameters, and it's going to be just equal to 0, just setting that available. No compile to OP code? That's what C and C++ do. Wait, what do you mean? Are you saying opcode or OP code? What does C and C++ do? Okay, so now we can actually do polymorphism for each one, so opcode. Okay, I see what you mean. Alright, yeah, essentially the same in each function we need to allow. So we can actually implement in each one. Oh yeah, we need to, yeah, I got that. Right, okay. I did it right. It's a virtual void except express visitor reference fee, yeah. Okay. Same thing for these last two. Okay. Looks like they all are set. We need to actually set them in here now. So let's say visit meetup visit article. So statement visitor should be up there. Should be for declared. Each of our values for this should be like that. And you can C++ do a lot more than a human can think of. Yeah, that's expected. It's been worked on for a long time. Don't actually know what's wrong here. Okay, so we overrided every single one. Did I forget like a semicolon somewhere or something? Oh, wait, no, I see. Yeah, I made a really bad mistake. It's not expert visitor anymore. It's statement visitor. How many keywords is your language gonna have? I really don't know. What I have right now is just a couple of them. Just I have the keyword in here. These are the keywords I have so far. I will probably add more, to be honest. This is just like a test run to see. We'll probably eventually add more stuff, and then probably maybe not OOP, but we might find like a different paradigm than OOP to actually implement. I'll have to look into those. And also, what is a GC? Maybe I'm not thinking of it right. What is a GC? Yeah, so these are all going to be statement visitors. Auto memory management? Yeah, maybe. Oh, you mean garbage collector. Okay, I didn't like put the words together. Yeah. I might though. I have to look into how all that works for the memory management and stuff. Isn't Rust auto memory management? So okay, article statement visitor, and we also need to change this one in here as well. For each one, it needs to be statement visitor. So let's just go through and change each one. Oh wait, no, it should be statement visitor. We want to change expert visitor and go through and change each one. Not anything in the structs here, but it should be for these ones. So these ones can start changing now. Wait, how do I? Oh, did I do the wrong one? Wait, Control H is the one do we replace, or no? Is it Control? Which one is the one that replaces? Just this one, right? No, we don't. Okay, wait, hold up, bro. Alright, okay, never mind. I don't know what's going on with that. Whatever. We'll just change it manually. Doesn't really matter. Just within these 4 or 5 functions anyway, so it's not like a huge amount of change. Yeah. Just these couple of them. Rust is like 50% auto? Yeah, it makes sense. Okay, now it works. So now we just need the separate ones for each, so let's call it like red statement. Is it red? If statement, while statements are there. If statement, but we're so close to being done with the visitor pattern, and then we can start the next part. Is it if statement? Oh no, it's called visit if, right? Yeah, visit if. I didn't write statement for any of them. While block, I believe, was also there. Block. And I think there's one more. I think it's like expression something. Let me check. Express statement, yeah. Control plus shift plus arrow will select word by word. Okay. Control plus shift plus what arrow though? Like that arrow on there? Okay. I think the visitor pattern is done. I think it should be good. Right or left? Okay, that makes sense. So now we have the node themselves and then the implementation they want to have for the accepts. Okay, so that's the visitor pattern done. Just making sure. I'll probably separate them out and say expressions. And say statements. Yeah, I think that should be good. Alright, now actually comes the actual fun part, the parser. Well, I don't know if it's fun, but we'll see. We'll see if it's fun. But yeah, we have the abstract syntax tree visitor pattern done. Now it's time for the parser, so we need to set up class for parsing. I do have my notes handy here. Oh yeah, I do want to talk about this stuff, bro. This stuff is actually very interesting. Like, actually, once you understand what it's doing, it's actually very interesting. We'll get to that in a second, though. But we need to start with the parser, just like the parser class itself. So we need to make that. It is not fun. Hey, maybe it's not fun. Do you get the shell working? I haven't looked into the shell yet. I will look into that. Either tomorrow or later tonight. Yeah, probably tomorrow. But yeah, so we need to start with... Okay, so let's just start by writing the class. So let's just call it a class parser. Alright, so what we need is... So essentially what it's doing is going token by token and defining meaning, right? So we know we're gonna need, just like how the lexer had a vector of characters, or a vector of tokens, we also need a vector of tokens here to go through. So we can just define a couple of variables. We could say like std vector. We'll take in tokens like how we did. We need to add some includes. We need to include. We should probably be including the lexer h. Likely including ast.h. Maybe just for this part. I'll see. I might delete it for not using anything from it. But yeah, we know we're using lexer for sure. Okay, so the class for the parser. So we need a vector of these tokens. So we can just call them like tokens. You can help with it if needed. Yeah. If you know some things, if I'm not doing it right, you can help me out with it. For the shell, I assume you're talking about the shell. When I get to it tomorrow, I'll let you know. And if I don't really understand what is going on, then you can help me out. Okay, so we also need, I believe in my notes it said we need a line number, and that makes sense because, not a line number, like occurrence of value that we're taking. Essentially just like tokens, how we went character by character, this time we need to go token by token. So we do need to have like a current value here. And let's make these private members since we're not. So let's just make them. They're already going to be by default private anyway, so okay. And we can set that to 0. The start of it, so. Before we move on, we should probably make our constructor. So our constructor will just pretty much just take that vector, I guess. So parser just a vector token okay, and we need to make it tokens token. So that should be a good constructor. Yes, I made the shell. I know how it works, but you need to do it on Linux for Bash. Yeah, I'll do it on my Linux PC once we do that tomorrow. But not only do we need a vector of tokens, we also need a vector to recreate like the whatever the parser parses out. So we also need another vector in here. And this vector will be accessed publicly because we need to actually implement stuff for it. So like, okay, so we kind of need like a function, just like how we had like these individual functions here, like, where is it? Yeah, our individual functions like scan token and scan tokens, just like how we had here. So one for scanning the individual character and then scanning tokens general. Same thing here that we need for our parser. And we want to implement like a function, kind of, I guess. And they're probably very similar, so let's make like a std vector function. And this function will basically I guess it should be taking in all our statements that we have. It should be taking all our statements. You should do it live? Hey, maybe. Okay, so it should be taking. Alright, so let me map it out real quick. So this is gonna be the vector of individual tokens. This will be a function that we have that will parse through all the tokens and return whatever we need to, assigning meaning. But each thing will be kind of like a like a statement, I guess. So I guess it would be a statement, right? So we're gonna probably be taking from statement. So we need to call that statement like we did yesterday. Statement, and I believe it's like this. Yeah, unique pointer statement, and let's just call the function like parse. Parse file, no, because like you can also do it in the REPL as well. Parse code, I guess. I don't know. Well, we can change names later. It doesn't really matter. Parse code. And all errors, store the errors in a vector, and at the end, before the person runs your code, print the errors from the vector for better error handling. Yeah, that's what I plan on doing. Yeah, so I guess that does kind of work. We do need our includes though, so include vector and include memory. Alright, so that should be good. And yeah, we probably do need a couple of helper functions. I do recall in here, and we'll probably add that at the end later. But we also need individual functions for each type. So as we know, we are making expressions for Pratt parsing, and we do know that we're making statements for recursive descent parsing. Because statements like if statements, while loops, all those are just top-down approach. They don't have any need for precedence rules or anything like that. It's just pretty much a top-down approach, so we can just do recursive descent for that. But Pratt parsing, we need to define more vigorously for those rules. So I guess we can kind of we're gonna need to basically declare each type essentially. So I believe, yeah, so we're gonna need one big function that essentially calls each underlying function that we have, for whether it's an if statement, while statement, or so on. That should be, okay, yeah, let's do that for statements first then. So let me see, in here, for statement, so I guess we're gonna need individual functions for each of these ones that we have, so we can do that. But first we need a overarching function. So let's call that like statement pointer. It's gonna be from the statements, and call it statement. And each underlying function, this function will handle calling any other underlying functions that we do as we're parsing it through, and we decide what the meaning is for each one. So it's essentially just going to be the same for each one. So var, we can call it like var typo statement. We've been using that so many times though. Maybe we want to make it a better name. So maybe call it like variable var declaration, maybe? Just so I don't get confused, because we've been using that name a lot. And make that a function. It's definitely spelled declaration wrong, but declaration, yeah, there we go. Okay, same for every other function like that. I'm just gonna copy the stuff like this since it's the same. We have for ret, we'll call that return statement, ret statement. We can call this one if statement. Do you want to hear something that makes my lecture run better? What do you have? What do you have on your lecture that makes it run better? Also for block statements. And expression statement. I believe that's good. So if while block red declaration. Okay, I think we covered it all. And okay, so this is going to be for the statements, recursive descent, parsing, and the rest is going to be for expressions. Oh, I can't even type today. Expressions, which will be towards parsing. Alright, this is going to be handled a little bit differently. It's not going to be as linear as regular statements. We're not just going to be going through and calling each one, so we actually need to think about this more. And this is actually where things get a lot more interesting for parsing. It's actually very, very interesting. So let's actually just go through this and kind of map our way through. Alright, Loki, let's pull up a paint file. Because we might need it. Alright, this is the interesting way that parsing is handled. They have something called a binding power, so it's basically like an integer value that gives precedence to, that basically gives the precedence value to each operator. So like, we know that plus and minus are basically the same precedence, so we can give it like an integer value binding power of like 10 or something, and we know that multiplication, that's a multiplication symbol, let's just go with that. Okay, and then division is also the same, and then we're gonna have to give it a higher binding power, and this is basically how the parser decides which one to favor, and I think that's very interesting to actually implement. Okay, yeah, we need to actually do that. So, for the equal, not equal to, you do self dot like some equal token kind equal else token kind equal to make it so you do not need to make a function that gets the next char value. Self dot like some equal. Is it similar to how I did it? Ghost? Like, in here in my lecture.cpp for any double character stuff. So let's say I had the case of equal sign. We did if match. So like if the next character we're expecting it to be equal, we make it equal, else just equal. That's how I did it. I feel like that's the same way that you did it, like looking at your message. Okay, okay, try parsing, so... Alright, there's two other things that we also do have here. We have null denotation and also left denotation. And this basically handles any prefixes. So if you have like a unary minus or just any singular number, I guess it'd be better if I explain it with an example. So essentially, let's say we have 1 plus 2 times 3. I hope I can explain this well. So we check the first number. Nothing is to the left of it. That's where null denotation actually comes in handy. So if nothing's to the left of it, it makes this a single left character for the null denotation. Then it moves on to the next operator. You made a function for it. I return token kind equal normal else. Token kind equal, so I don't need to add more functions. I believe for mine, I made like a full function scanning each individual token, right? So for each single character, it's just to append that token. But for every subsequent case, for like slash, we need // so we need to check that case. Not, we can have not equal to or just not, so we check that case. So they're all in like one function. Let's go back to the part. Where exactly was I in the explanation? So we did the one null denotation. Yeah. So yes, the null denotation calls that. So we're basically calling nud of 1 when we implement the function. Then it looks at the next token for plus. Plus will have like a certain binding power that we have of like, I don't know, 10 or 20 or something like that. It is greater than the previous binding power, so we allow it to enter like a loop essentially. And that's where we would call the next function, the led function. So we already know the left hand of this plus is 1. So that's the value on the left. Then it looks at the value on the right. So we have the 2 here. So then this is going to be an individual token itself. So we also need to recall the nud function as well again. And then we'll be checking the next character, but multiplication has a higher binding power than plus. So that means we enter another inner loop to handle this statement itself. But once we exit this loop, we will hand that back to this plus to do the operation on 1, its left node, and also its right node, which will be 2 times 3. So that's essentially how we have to handle that with parsing. Seems easier said than done to actually implement though, so let's just go through it step by step and try to do that. Ghost, you're gonna have to like send me a code snippet. I can't like really understand from that. Like I know you didn't make a function for it. Okay. So we probably want to have, as we said, our null denotation function as to handle those tokens that don't have anything to the left of it. And we need a separate led function. So let's just kind of map it out. So our nud function is going to just take one parameter, which will just be the singular value that we're taking. Let me bring up that example again so I can just like look at it. So 1 plus 2 times 3, right? We're just calling nud of 1. There's nothing to the left of 1, so it's just allowing that singular value to be there. And So node should just have one parameter. But for the case of lead checks the values to the left of the current operator that we're having. So lead should be calling the left value, which in this case, the left of this would be 1. So that'll be one parameter that it will have, and also its current parameter. So I guess the current parameter, so I guess just that. So yeah. Oh, it doesn't work in C++. That's interesting. I'm not understanding. Like, I kind of get what you're getting at, but I don't know like implementation for C++. But I guess yeah, it doesn't exist in C++. Mine shouldn't be too bad though. This should just be essentially just one jump table. We just access these really quick. It should be like lightning fast to access each of these. I don't think mine will be too slow for that. But yeah, so for the lead function, we're checking the left and the plus. But to grab the right, I believe we're delegating a different function to be handling the right part of it. Yeah, I assume, yeah, so we'll probably have another function here. So nud, lead, and we probably want another function. Well, okay, so the right node is just another loop of it, right? Yeah, the right is just another loop. Just entering another inner loop to actually calculate this. So this should be fine, but we probably do want to have a way to check the binding power. So let's call, we can probably make a value like int binding power. And it would probably take like a token value itself. So we're taking a token for binding power, and yeah. So that should essentially just give us our value, and probably we do want a way to actually parse the expression, so we probably want another function here. Okay, I think I kind of understand how we might implement. Let's say I'm gonna just do the first ones that we know for sure. So it's gonna be unique pointer. These should just be for the expression itself. So expression, and we'll call it like nud function. And nud should essentially just take a token value, token from our list of tokens we receive from the Lexer. Oh yeah, I understand what you're saying. The match is adding more functions than needed. Yeah, that makes sense, yeah. I don't really know if there's a way to do that in C++, to be honest. Other than, like, hard coding it, but I don't know. That's not really a good plan. The overall speed should not be that much changed, so I don't think it's too much of a detriment. Yeah, but this is already fast enough. I don't think I need to make a hash map again. Because the hash map itself does add some overhead to it. yeah, so nud will take, yeah, just take the one token, and yeah, add a forward declaration to that function. And we want to take staging pointer of expression, and probably call the LED, probably make an LED function, left denotation, and this will be taking a token operation and also a token. Well, I guess it would call but I guess we want to take the left value itself. We're not passing it in by itself, because we don't know what that value might be, so we want the compiler to take over there and actually set that. So we probably want this to be again the pointer itself here of expression. And probably just, yeah, I'll call it just the left value of that function. We can call int binding power token token. So this will essentially get the token for that and check if it's a and just check its binding power essentially. And what else? Well, I guess we need a way to actually parse these expressions. Right now we just have the individual stuff, but we actually need a function to parse it. So another function up here. Unique pointer. Let's call it parse expression. So parse expert. And what would that take? What values would that take? Let's think about that. What values is it taking? Well, the main parsing is just defining these rules and allowing, and to see whether or not we need to parse this way or parse that way. So I guess we're just probably taking the binding power, right? Binding power. I assume, I'm not actually sure though. Let's think, right? Let's think. So we have. So this will be handed to the nud function to grab that singular token. It goes through to the next token to grab the plus. This we'll call the led function. So that would be checking the value to the left of it. And checking if we should move forward. And then we move on to 2 here. This will also be singular nud here. Then it checks the multiplication. This would have a higher binding power than this. So it enters its own loop. And then does the final one here. Evaluates this, and then passes that back as the right node of this. Okay, I think that's good then. I think the only thing we'd really need as a parameter is just to check the binding power. This would be like checking that. Yeah, probably like that, yeah. I'll leave those comments in there if you need to go back and do something with it. But yeah, we also need our helper functions too. Just like how we had our helper functions for our scanner. We need to have them in here like that. So what exact helpers do we need? Let me check. I know I wrote it in here somewhere that we need. Okay, yeah, so match. We need match. Okay, this is, yeah, it's very similar to the Lexer. Like, this checks the next token. This consumes the next token that we need. Yeah, let's just do that. And peak and previous as well. Peak looks at the token and current without advancing. Okay, so yeah, alright. We're looking at the next value, at the current value. Okay. Alright. So match is probably just gonna return something like how we did in Lexer. It's gonna return a bool value. And what was the description? Are we just passing in a token value or? Use the initializer list here to take a brace and close the list of token type values. Okay. So we can use initializer list. What is that actually like? Let me see. Is that like an actual thing, or do I need to implement that? And it's defined with the header of initializer list. Okay. So that will allow us to essentially use that, I guess. Oh, I'm missing. Okay. Alright, there we go. I was looking through, I was like, did I spell it wrong or what happened? Okay, what are we taking? We're taking the token types that we need. So token type. Types. Let's just call it types. So that will be for that function. Next, we need to do consume. So consume would probably... What is consume actually doing? Let's see, so... Let's have closing parentheses, consume. Alright, so the token type that we're having. Okay. Yeah, okay, so we just want to return a token type, I'm guessing. We're checking that token to make sure it's valid and returning that token back. So token, yeah, so token consume. So first off, the token type, and also a message if they do it wrong. So const, you can just do constant string message there. What happened there? A constant string reference message to a message. Okay. What does your emulator do? Okay. So that basically takes in raw bit strings, decodes that instruction, and then passes that off to the risc-v interpreter section. The decoder decodes the instruction that we're needing and passes that to the interpreter, and the interpreter does a 5-stage pipeline. So instruction fetch, instruction decode, instruction execute, and instruction execute is where it actually takes the decoded instruction part and actually execute the ALU operation or whatever operation it needs to do. Then passes that off to the memory pipeline stage, which only happens for load instructions and store instructions, so any ALU operation should skip that phase. And then finally reaches writes back to a destination register. I do have a couple of videos of it on my channel, basically going through how I essentially made this. Like my past streams are all about the emulator, so yeah. Yeah, it is with my coding language. This is the compiler and this is the emulator here. Once I get to the backend is where I connect these two. So yeah. Okay, token consume. So checking the token and then returning the token type back if it's valid. What's next? Peak and previous. Peak and previous, yeah, they don't need anything. So I guess you're just checking the next token and returning that token back. So token peak, but we don't need any parameters. And since we're not adding any values, we can probably make them const. Token previous, I think, right? Yeah, previous const. Yeah. Hey, what's up, Swan? How you doing, bro? And what's up, Amit? Yeah, this is just a compiler for this is a compiler that basically takes a subset of C and then feeds that to the risc-v emulator, and the risc-v emulator will essentially just be acting as a CPU, basically. So instead of taking like an actual architecture that's already made, like x86, I made my own like version of risc-v and actually implemented that in an emulator version. All right, let's keep moving forward. What's the purpose of initializer list and match? I'm pretty sure it just returns a brace initialized list of a bunch of values, I'm pretty sure. I just remember when I was doing my research about it, that's how it's mostly implemented for that part. Okay, what else is there? What else could we possibly need for our helpers? Probably not much, right? I think. Well, we probably do want functions to advance, right? Like how we had in our Lexer. Lexer.h, yeah. So probably, do we need an is at end function, and do we need an advance function? I mean, I'd assume we probably do need it because we're going token by token, right? So we want to actually make sure that we advance properly through it. Okay, let's see. Yeah, let's probably maybe add it. If we don't need it later, we probably will remove it. So we're advancing tokens, so we want to advance tokens forward. And I don't think it really takes anything, right? In the Lexer, it didn't take anything. No, it didn't. And is that end function, which will be return true or false. And this can be const, because we're not changing any values. I think these are all the functions that we need. An optional consume? What do you mean? What do you mean by that? There are some languages who allow for if to have a parentheses and also not, but also allow them to be optional. Oh, okay, I see what you mean. Should I do it like that though? I don't know if I want it like that though. I feel like I want it to actually be within the parentheses. Just for readability's sake, I guess. Yeah, it's a matter of taste, yeah, I understand that. Okay, I think this should be okay. I guess we go through and just implement whatever we can, I guess. Try our best to. Alright, so I guess we can start with recursive descent parsing. These are statements that we're parsing through, so if statements, while statements, return statements, these are all very linear and they don't need any precedence rules. You can just go line by line and go through it, as opposed to expressions where you have precedence rules with multiplication, addition, and many different types of operators. So that's the second part. So let's first start with recursive descent parsing. And we'll just go function by function. We'll go through however much we can. And yeah. Alright, so Parser, let's see, we're probably going to need to implement it here. Do you want it like JavaScript or anything good? I'm not actually sure. I'm probably like moving towards C style, something like that. I feel like I'll have more of a clear vision as I go through and actually do it. I feel like I don't have any inspirations right now. It was kind of like an on the spur moment thing. Like I made the emulator and I was like, oh, why not make a compiler? It really fits together with it. So I guess I really need to sit down with myself and think about like the goals for the language and not just have it be a C copy. I probably should do that, yeah. Most important thing is the name. I'm really leaning towards that V++ thing that you said yesterday. But I'm gonna have to see. Alright, let's start. Okay, so we're gonna need to include our parser.h And probably have a bunch of more close back there. String. We're gonna be using unique pointers for sure, so memory. Yeah, let's just work with those for now. Okay, let's start with the first part. Unique pointer for the statement. Unique pointers for the statement function. This will handle every other function. So this is like the main function that handles all of these smaller functions, depending on what the statement is. So let me just grab the declaration of it. And we want it to be... do we have it? Wait, I'm forgetting for a second. Yeah. Parser statement, yeah. Oh, by the way, is everything a statement in the language? Probably. I mean, we have like the sub part of a statement. Expressions are like the sub part of statement, like a sub statement. The expressions will be handled individually and then be passed back to be statements. I believe I did that right. What is the problem there? It should be after the data type, yeah, for that for the namespace and scope identifier. You should try new of him. Maybe at some point. I don't really see what's going on here, but maybe... Okay, oh, it wasn't even a problem, I just didn't implement it, so... I was overthinking it, yeah, okay, so let's implement it now. So that is the right way. So this statement will essentially call each of these statements depending on what our token is. So I guess this is where we could probably use the match function here and taking in that whole list of that if statement or whatever statement we have. So let's say, little brain fog here. If match, and we'll say, what is the parameter? I think it's token. It's the initializer list, so. Say if, I don't know, we can't do this. So what if we don't make it as the initializer list? But I guess no, wait. Let me take a look at the initializer list. It should be in a brace and closed. So essentially, if our where is it? If our package for the if statement, I can't find it. Where is it? Oh, here. Okay, here. If our package for the if statement, if we have these packaged within a brace initialized list, potentially could use a polymorphic block to handle the statement plus X per chain later on. Possibly. I feel like, yeah, you're a bit too early for that. I'm thinking as we go. So, like, I kind of have like a plan of what we're kind of doing, but the implementation will mostly be as we go. Yeah. So I guess, okay, so if we make this within a brace, then it's probably allowed, right? Okay. So if it's a token type if, and it will match this part. So I guess just call that function, right? Call that specific function, the if statement. And essentially the same thing for every single type, I believe. So let's just copy. I'm gonna go in order as how I said it. So var ret if. So variable declaration. Return. I believe the token is return. What is it for? I guess just identifier, I guess, for the red statement. Variable declaration. Variable declaration would just let me look at the implementation for variable declaration. What exactly we packaged in here. The name and the initializer. Okay. No, there's no IR yet. I just did the lecture and I'm working on the parser now. And if you use LLVM later on, if you use ret as return, it will be faster because LLVM uses ret. Yeah, that makes sense. I believe that risc-v does have LLVM support, so I think that should be fine to implement LLVM later. After I implement my custom backend though. First I want to make a custom backend and then maybe have the LLVM after. Custom backend just so I can learn what the backend is like. Okay, what? I'm kind of confused on the variable declaration, what we might do there for that. I mean, I guess it's just taking a type, right? So what are the types I defined? Here. Int, float, void, char. So if it's any of those types, we're declaring something. Okay, yeah, probably something like that. Yeah, let's probably, so we'll probably have a bunch of them, right? So it can be token type int, possibly token type float, token type char, and token type void. And just have a bunch of them like that. And if that's the case, we return var declaration to actually grab that stuff. Backend equals hell. I mean, that's the best part about it, right? We gotta jump into the hard stuff. What's up, Lucy? How are you? So we have match the next one, which will be, the next one is while statement. Let's do while statement next. So, token type, and we'll call it, so while statement is just gonna be the while keyword. And we'll call it while statement. I'm doing good, I'm doing good. Okay. Block statement is there as well. Okay, so for block though, block we don't have a special keyword. 12 people watching? That's very interesting. Very interesting. Feel free to join the Discord in the link in the description. I'll also make it the pinned message here. Double digits. We actually hit double digits like every stream for the past couple days, so that's really nice. New here, what's up, AJ Brady? May I ask why CPP and not Rust? I mean, I would do Rust in the future, just not right now. Probably the thing is I'll probably do either Rust, Zig, or Odin in the future, but right now I'm doing C++ because it's more of the industry standard still. So if I eventually try to apply for like compiler roles, I'm probably gonna have more of a chance to get that in C++ or C. But that doesn't mean I'm not gonna learn something like Rust or Odin or Zig in the future. Do not do Zig. I mean, the thing is, like, people say, okay, this is a problem because the Rust enjoyers say Rust is better, the Zig enjoyers say Zig is better, and then the Odin enjoyers say that Odin is better. And it's just like a complete fight between each. So I had to do like a deep dive of each one before I actually get into it. Yeah, what did Zig do to you, bro? What happened, Ghost? What did Zig do to you? Alright, okay, so block statement. What? Okay, block statement, how do we, let's see, block statement, what is the, wait a minute, so basically a block statement is defined once we reach this brace, right? And then we have the body of it. Okay, so I guess we're just checking if it's a left brace, right? Where's the parser CPP? So we're checking if the value is a left brace. Left brace. And if that's the case, we are returning block statement and that function. So I've Verdic, red if while block, and now we need expression statement. Not void? What is not void in Zig? How do you even have not void? Doesn't not void just mean that you're returning a type? Is Rust faster? I feel like all those languages are like really very similar in speed. I thought like people were saying that C++ is a little faster, but Rust has better memory management. Oh, I appreciate it, AJ Brady. Appreciate the sub and the Discord join. Yeah, I feel like they're all like the same. But it's just like a personal preference on what you like to enjoy, I guess. Yeah, it depends on the benchmarks, yeah. I don't know, it's either between Rust, Zig, or Odin, but that's in the future. That's like next year. I'll try to get it. Like, I'm still not that comfortable with C++ yet. I'm only like a couple months in on C++. I still have a lot to learn. Like yesterday when we encountered some error in here that I didn't know how to handle. I just need to learn my C++ language knowledge better. Okay, okay, yeah. So we're doing the expert statement now, so. What constitutes an expert statement? I mean, it's just the expression, right? So Because we're passing the expression back. We're passing the expression back up there for that to be actually happen. So the expression that gets evaluated here, we're passing it to a statement. But I guess we don't really need we don't need a separate expression statement, do we? There's not really like a way to match that here. I might omit that for now. And I'll probably just comment it out for now, because I really don't know what... But we'll see. Maybe Rust is just better. Even within unsafe, you still get bound checks and checks for overflow in the assembly output of Rust. All Rust is unsafe, but in Rust you can pick what is unsafe or not. Is that the case? I wish I could provide some value on that, but I do not know any of those languages. I need to do a deep dive of each one next year when I get into it. My brain right now is leaning towards Odin, but I don't know. I'll see. My mind can be swayed pretty easily on those things. And who knows, maybe another language will come out by the time I get to them. Golang's also another option, but I hear like most people really shit on Golang. So, okay, let's think what we need. If a new language comes out, it'll be your language led. Hey, why not V++ here that I'm making V++? Who knows? Yeah, it could be both. But if those languages were to become industry standard, that would be like when we're long dead. Or probably like very old. You seem to know a lot about languages and language features, Swan. How long have you been coding? Okay, I think we covered all the statements. But, to actually parse each one. I mean, I guess we can just say I guess we can well, it's up to the parser to decide what expression we're actually in. So we probably want to say something like, it's not really known what type we're doing. Kind of stuck here. Maybe something along the lines, since we're parsing the code itself. Probably like an auto. What should we say? Yeah, actually not that sure about this, to be honest. I mean, I assume it'd just be like, oh, well, we can't use that, it's probably a keyword. Like auto expression, probably. I'm not really sure. Maybe something along the lines of parse code. The parse code function that we have up here, or yeah, the parse code function that we have up here. I'm not actually sure. I mean, I guess. Oh yeah, Ghost is making a shell. Yeah. I'm making a shell. What more should I have? Little config, color syntax. Yeah, I'll check out your shell tomorrow. It seems very interesting. Yeah, I feel like most people hate autocomplete. To be honest. Okay, so we're parsing that. I'm not exactly sure about this line though. But we need a way to parse through it, so I guess that would be the line. I'm not but then we need to kind of consume the tokens that we got. So we know that we're entering the if statement, but we need to actually consume the tokens and check if they're actually valid to see if we have the actual valid if statement tokens that we need. Or no, that would be handled with the specific functions. So after a specific statement, I think more so people hate autocomplete for coding itself, but maybe in shells they like it. But do shells usually have autocomplete? I feel like shells don't really have autocomplete, so I don't know. Maybe I'm wrong. I think it'd be more useful for shell commands because nobody really wants to write out shell commands by themselves. Okay, you know what? I might actually ask Claude about this part. Exactly. Yeah, I might do that in a second, but let's take a break from that part and let's implement specific functions. So, what do I want to start with? I feel like if statement's probably the most fun to do. So let's do that. So, Parser, if statement. NA shell. Fish is a great shell. It's also written in Rust. All right. Okay. So the if statement function. So, okay, so we already hit the first part. So we already have the first part going. So we already covered the if part. we hit the if token and we then call that function. So we hit that if token, but now we want to check like a parentheses, a condition, and whatever block it's in, and then also else block, which may be a null pointer because it could be optional if they include else or not. So will local scope pointers and variables be properly collected? Or is it just like C's philosophy? To be honest, I don't know. I'll have to look into that. I don't have to make it exactly like C. Like, I don't understand all like the very complex language features yet. I assume I probably will as I keep reading about stuff, but that's probably where I'll tweak the language to actually represent what would actually be good for the language. But I have to actually learn about stuff like that. Like, I have to learn about how memory management is implemented and stuff. Yeah. To be honest, like, I just started learning C++ like a couple months ago. Like, beforehand, I was doing Python in like my first year of college, but now I'm in my second year of college, and I just picked up C++ in March, maybe mid of March, and I just learned a couple of the very basic features and immediately threw myself in a huge project like the emulator. And I feel like I learned a lot about like designing stuff, but I don't actually think I learned too much about the language features, which I will probably get better as I go. As I keep programming different projects and also reading about stuff. So it's probably just going to take some time. Okay, so the if statement is once we hit the parentheses, left parentheses. Right, so once we hit the left parentheses, so we want to check if that token is valid. So we'd likely want to consume a token type of right parentheses. And then the error handling message, if they don't say it right, will probably say something like expected rates after the if keyword. I think that's fine. C with functions has to be an 8. You just graduated uni? Hey, congrats, man, congrats. Wait, really, Ghost? Nah, you gotta be trolling, Ghost. You gotta at least be in like high school or something, bro. There's no way you're in middle school. Or did you drop out or something and that's like a little loophole there? Okay, so that should be right for that. Oh, okay, wait. The condition itself is an expression. I remember we talked about that earlier in here. If expression, so we kind of want to hand that off to the Pratt parser because we can possibly have some condition, maybe like, I don't know, x equal y, and in that case we need the Pratt parser to actually see what is actually going on. If we have like a lot of precedents and stuff like that we actually need to handle, we probably want to pass it off to the Pratt parser. So after consuming the token, the Pratt parser will just basically depend on whatever the type is. So we can probably say like auto and probably write condition because it's a condition for the while, not the while, the if statement. And I believe you should just probably call the function for parse expression. But what parameter? Jai also support that. I've seen that in my recommended. Like there's a recent video saying like the world is not ready for Jai or something like that. I need to check out the video. I assume it's like a language or something. Damn, you're in middle school, 8th grade, dude. That's actually amazing. Starting that early. Yeah, making me rethink my life, yeah. Dude, back in middle school, I was just playing like Fortnite and stuff, dude. Call of Duty and all those random games. I did not even have like a thought about any of this stuff at all. I'm not actually sure. Do we just initialize 0 or maybe this is the time to ask Claude about it. I usually come to Claude when I have like no idea where to go from here. So let's give it my parser.h that I wrote, and let's also give him the parser.cpp and tell him my problem of having currently. Condition of if statement to parse expression. I wrote a parameter for the binding. I believe I called it binding, right? Yeah, the binding power. Binding power. But not exactly sure. Oh, you know the professor that did that? That's interesting. Hacking on Linux. Hey, Ghost, that's pretty impressive, though. Okay, so let me read this. The reason is that 0 means to parse an expression with no minimum binding power. Any operator with binding power greater than 0 will be included. Yeah, that's true. Beautiful expression. Okay. But I guess we'll probably change that name to min binding power. And let's parse passive 0. Bug bounties? Damn, Ghost. Yeah, Ghost is gonna be like... I can't even imagine where Ghost would be a couple years from now. Like, I'm 19 right now, so second year of uni. I can't imagine how he'd be in that time. In the parsing, don't you need to give up for precedence? Yeah, I believe we do. Okay, so parsing the expression here, I believe Claude did complain about something else that I wrote on my consume call. Well, okay, I don't think Cloud understands what my consume call is, though. This would mainly be for error handling after. Okay, let's move on. So after the condition that we pass to the parser for the prop parser to do, then essentially we just want to check for the right token. Or oh, okay, no, I see what he meant. I see what he meant. This is the problem, right? I believe. Yeah. Okay, I misread him wrong. I didn't even see that problem. Okay, that's good. Catch. This will be right parentheses. Sorry about that, Claude. I doubted you for a second. Okay, this will be expected right brace after condition. So after condition, we'll say. And I think that should be fine. And yeah, we'll add the periods there too on each. Probably better. What else is next? So we go through calling if, we hit if, go to the left one, right one, the condition, then right one. Then we hit our block. Ghost gotta find some perspective on the language stuff without the Rust evangelism. Yeah, Ghost does really love Rust there. I thought that most people say that HTML isn't, but some people might consider CSS one. That's at least what I've heard. Because isn't HTML just tags, right? Essentially, like, I don't think you could really call it a language. Primogen said it's a coding language? I feel like Primogen would say it's not. Okay, so we handled that. Let me look back at my abstract syntax tree here. So we have the if statement here, so the condition, then we have a branch, and we have the else branch. So we need to cover the branch and else, the else branch that we have. So this is kind of gonna be, a branch is kind of gonna be like the block, right? It's just gonna be a block statement. So could we essentially just say like auto branch, and then call that, we can essentially call statement again. So it will, depending on what it decides the type is, it will call the block statement, because we reached the brace, right? So it should be so I think that covers, so that will delegate it off to block statements. So I don't think we need to worry about implementation there. What's up, Eamon? Building a compiler here. Right now it's a C compiler, but who knows, maybe that might change in the future as I decide what I actually want to do with this for the future. Should you try Zig after you make lead? Yeah, lead's his coding language that he's making. He's like doing a, not like a race, but he's doing it alongside me to see who makes the better one. Something like that, just like a friendly competition. But yeah. I thought you hated Zig though, Ghost. You're really gonna try Zig? Alright, so that covers branches. We wanna cover else block now. So else block will happen if we hit the else keyword here. So I guess we can maybe kind of do a similar thing here, but inside this function. So we can say maybe like if match, and have the token type be else for that specific keyword that we have, the specific token. If that's the case, then we can do the logic for that part. So I mean, else, this is also just a branch, so just basically auto branch again. But we can't make the same one, so I'll call it maybe like else branch, maybe, probably. So that figures out what it is, and then does it like that. I've used or tried Go, TypeScript, JavaScript, Lua. Dude, that's a lot of languages, dude. Oh my god. How do you even get to that much languages? Let's see, so I probably worked in a little bit of Java stuff, but I totally forgot Java. Python for uni, C++ I learned by myself. A little bit of Lua, that's it. And that's pretty much it, I think. I don't think I know anything else. Oh, maybe a bit of JavaScript, but I didn't really go that deep into it. I kind of pivoted over because I didn't really like it. There's already a lead language? Dang. Yeah, Ghost, why don't you make it like, why don't you make the name something similar to Rust or something, since you really love Rust? Robust? That's interesting. Okay. I think that covers else. I think it covers else, but now we want to return our, basically returning our specific statement here. So we have the condition branch and else branch. So possibly return unique and make that the specific if statement that we have. And I'll probably make them so we need to call std move to actually use them because we can't copy a unique pointer, so we need to call std move on each value that we have in here. So first would be the condition itself. I believe, let me see the parameters again. Condition branch and else branch. So condition branch and move on the else branch. No instance of overload functions to make unique. Shouldn't else branch be null first? Time and expiration, yeah, that makes sense, AJ ready. Renaming it to doc. That reminds me of Docker. Wait, it should be null, right? Okay, you make a good point. Hi, I'm on Windows. I see you guys realize that I am. Yeah, I'll move at some point. It's just like so much like so much stuff that's being thrown at me. I have Linux on my other PC that I use, but on my main PC here I haven't switched yet. There's like so much different stuff that's being thrown at me. Like people have told me to learn NeoVim and learn this language, learn Linux, and like it's just like, damn, it's like a huge bombardment of just a bunch of random stuff. So I'll eventually get to it, probably. Maybe very soon. Yeah, so wait, okay, so you did mention we need null here. That's for the else branch because it might be a null pointer. I see what you mean, so... I don't know for sure if it's called B++, I just might. because there is something in risc-v, there is something, you are allowed to have vector instructions that basically takes a bunch of assembly instructions and put them, CPU instructions, and puts them, does a whole like batch at once, vector instructions. And that's a very interesting thing I need to look into. And that vector, the v in risc-v is vector, so maybe my language could also be called v++ to like reflect that. But I have to look into that stuff. That's if I implement a vector for my CPU emulator, vector instructions. So we need to make it a null pointer, so I guess unique pointer, and since it's going to be a separate statement, we want to make it like that. So just a unique pointer statement, and maybe call this else branch and make it a null pointer. And at this point, do we need the auto keyword since we already have it like set there? Okay, that's fix it. Yo, I appreciate you mentioning the null part. I completely missed that. I think it was Swan who mentioned that. I appreciate that. Yeah, appreciate that, Swan. Okay. And then return needs a semicolon there. But what's the problem here, though? Did I not put it everywhere that I need? We have it here, we have it here, everywhere. And we have it after the return, so what am I missing? Okay, I just need. Okay, what? I literally just saved the file and the thing went away. That's interesting. Okay. There's a lot of engagement in chat today. I appreciate you all for that. Let's do the next function. So it is 12:30 a.m., so I might end up ending the stream soon. Let's do parser for. Let's do the while statement. While statement might be nice. We all should make a coding language and then make a GitHub repo with all your languages in it. That'd be something. Okay, let's see how to do the while statement. Also, I guess up here it would have been the same issue that I had earlier, so parse expression 0. Yeah, so we parse expression. Okay, so while statement, let's kind of map it out and see what we kind of have. So once we hit while up here at token, it will essentially be the same exact, it's essentially the same. So we have while condition, we have a block. Just the only thing is that we don't need like else or anything. Does that exist? Like, I feel like I've seen that somewhere, like while and else. I don't know. I don't know. But let's just do this for now. So we have. I think we can just copy, to be honest. So yeah, this should essentially be the same with the right parentheses. But then we're going to reach our body, which we do the same thing. We delegate the branch part of it. And I'm going to call it body, since I remember we did call it body in our AST. Yeah, let's call it body there. We'll delegate it off to the statement to enter the block. So the statement will enter block as it deems fit. Alright, good night, AJ Brady. Appreciate you for joining the stream and joining the Discord as well. Isn't the while loop with 3-parters? What do you mean? Do you mean like, because I know that, do you mean like do while, and also for? Because I do know that under the hood, a for statement is, a for loop is just like a while loop implemented. Oh wait, the assignment condition in the increment form. Yeah, so I understand what you're saying. So like people might say, okay, let me just have like, some comments here. Like people might have like an int x. No, that's a for loop, I believe. No, you're kind of saying it right. I understand what you're saying. I feel like you're saying it like this. But this is not implemented though. For a for loop, it's like the int x. The int x, the 3-parter. So x is less than something, whatever value you have. So something dot length. If you're doing like a vector or whatever. And then plus I. But for while loop, it's just delegated by itself. Like you have the variable before the while loop, like int x. You initialize while x is greater than or equal to 3. Or whatever value, greater than or equal to 0. Then you delegate your body here. You write your body here. And then it will be plus while loop under the hood. I remember reading about that somewhere, but I do need to see how that is implemented. I mean, I guess we could kind of think it out, but that seems really complicated for now. Nah, you're good, bro. You're good. Yeah, we only parse. It's very similar to the if statement. It's very, very similar. So yeah, so left parentheses, the expression, the condition, the right parentheses, the body, which we do. Then I guess just return it. So return stood make unique. For the while statement. I don't know why I did the parentheses. And we're gonna be calling stood move on the parts. So I guess it's just a condition in the branch. Not the branch, we called it body here. I'll probably stream for maybe another 5 to 10 minutes and probably end the stream. Yo, what's up, Online Max? Welcome to the stream. Doesn't parse expert consume too many parentheses? Yeah, what do you mean by that? The parse expression is to pass it off to the prat parser, which I actually haven't implemented yet. because our condition could potentially be something like x equals y, or I don't know, x greater than or equal to z. So this is where the prep parser needs to take over and give precedence rules to whatever we're actually working with, because yeah, we can have a bunch of different precedence types and we need to know what the binding power is. So it's not linear in that case. So that's why we're passing it off to the prep parser, which we haven't implemented yet, but we will later. Probably tomorrow. I probably won't get to the prep parser today. I'm probably not even going to finish the statements today, the recursive descent parsing. So let's do make unique statement. What did I do wrong? What happened? What happened here? Oh, is it this? Yeah. Yeah, parentheses, I think I'm just consuming it, but the actual condition itself is passed off to the prep parser and it will be given back here. I didn't implement it yet. Okay, I'll probably do one more. Your language has 17 keywords, Ghost? Nice, nice. What are the keywords? Like, are they the same as mine, or did you implement anything new? I mean, I assume you implemented some new stuff, because I didn't have 17. I had like maybe 10, 8 to 10 max. For now at least. The next one is, let's do return statement. That might be interesting. Yeah, let's do return statement. I'm just gonna have it in order of the way I declare, so it's gonna be here. And it's parser, namespace. Alright. For the return statement, what we have is basically like return. Once we hit the return keyword, it's just gonna be the expression, I guess, right? Return keyword should just be handing that off, I believe. What did I write in here? Just, yeah, return expert. I see, you're going for something similar to a Rust, I guess, if I got that right. Yeah, but yeah, okay. That's an interesting question you posed, but I need to see. We'll figure it out as we go, because I kind of can't think that far ahead, to be honest. Return statement, return an evaluated expression, or just a raw expression? I mean, I guess the evaluated expression, probably, because that would probably be evaluated by the parser, I guess? The prep parser? I'd assume, right? Oh, it's like real, I can see for Mio. Okay, but for this case, we also have the... Are we gonna do the semicolon? But also, for the case of... What about for functions that just return? Just like literally just return with a semicolon. I think we also need to cover those. Those also do exist. Are there any other edge cases for that? It's mainly just an expression or just returned by itself. And that would be just like return early out of function for... So, I mean, I guess in that case, the expression itself could be a null pointer, right? So, like, our unique pointer of that expression value of that expression, if we have, I don't know, value, and we say, we can probably say it's a null pointer, it could be. It's very similar to the while, not the while, the if statement for the else part. It could or may not, it may or may not have a return like expression there. But we need to check if it's not a semicolon. To resolve an empty return, do you just skip the expert step? Well, you need to check the return type first. Yeah, I think you need to check the return type first, but is that resolved here? I mean, online max says that's after parsing, so that's probably a different step. For here, I'd probably just check. We can always change it later if that's not the actual implementation. I can do some more research into how people actually do return. If it's not... Okay, so what function do we need to call? Because we've already hit return, so our next token that we're advancing to is going to be this one. So we just need to check if the current token is a semicolon. So let me check what the exact helper function would be. Do we have one? I don't know if we have one. We have one for previous. Well, we need to implement these functions later. Or we should probably do that now to actually understand how they probably work. I know how they probably work, but I just need to implement it. I know the description of how each of these would work, like off the top of my head, but we don't have one that returns a current one. Maybe that's a task for tomorrow. To print it is printf. To make var is let xi32 equals 10. Interesting. When we go live tomorrow UTC time, should I make a proper stream schedule? I usually stream around 10:30 p.m. EST. We can do like a time zone conversion right now. I don't know, we can check. Or do we not have like a UDT thing that we can actually check? I mean, I guess you guys can just check what the time zone is, I guess. I'm in Eastern Standard Time. Or I guess it's Eastern Daylight Time now. Or whatever that T stands for now. Yeah, it's 12:51 here. I don't know if I should start streaming earlier or like... I'm definitely not doing later. Like 10:30 is probably like the latest I start, maybe 11. But I don't know if I should start streaming earlier, if that might be better. So we can actually keep the streams going on longer. But maybe though. Yeah. Maybe we can call like I don't know. Maybe we can make like a new function here that checks the current one, that takes the current one. Maybe let's call it like... We're gonna need to return true or false, so probably like a bool, maybe a check function to check the current one. And we'll take the token type of it. And this will check it without returning like any error message there if we didn't do it right, so. So if not check, the token type, right? So you will make it U8. The lecture's not done. What part of the lecture are you on right now? Do you have like string handling done? Numbers? I believe you're somewhere around there. Honestly, I need to take a day and kind of just map out my language. But also the problem is I don't understand like really complex language features yet, like memory management and stuff like that, like any other very advanced topics, because I'm still learning C++, so like I don't know how different languages do. So I probably need to take a day or two, probably like do a deep dive into like all those concepts and kind of figure it out. But I don't want to make this too complicated because this is like my first time writing it, so if I go too complicated I might get burnt out. I don't know, is that like a good idea to maybe just implement this basic version first and then add complex features later? Because I'm also going to be writing the backend myself here too. I'm not using LLVM for at least the beginning to actually implement the backend myself. I don't know, we'll figure it out. How long would that be in weeks? It's like the end of May, so around 2 months ago, April, March, like somewhere mid-March, so yeah, maybe 2 months, maybe 8 weeks. Yeah, Rome was not built in a day, that's true. That's very true. Yeah, it's probably gonna take a long time. But yeah, hopefully I learn more as I go. Because this is some interesting stuff, but if I hope I don't like burn out or like, I don't know, mess up too badly. Yeah, consider that consistently makes practice, yeah, that's true. Yeah, I guess I kind of am already going to complex stuff. I do really get confused on language features though. I think it was yesterday I got really confused while making the visitor pattern. Because I didn't know you need to forward declare the struct to actually use it. I had like a circular, I think it's like circular include problem, I just didn't know what it was, so I had to ask Claude about that. And then also the fact that you can call override in the header file, but you can't do that. You shouldn't do that for the CPP. I was trying to override in here too, which made a problem. Yeah, not gonna lie, the visitor was really, really confusing yesterday. Like, I wrote out my notes. I write notes before I stream to just understand the concept, and I go through it and kind of try and implement it, but that one kind of took a lot out of me to get, and I still was really confused. Yeah, you've been there before? Yeah, I feel like I'm gonna encounter problems like that a lot. More so, my strong suit would probably be like reasoning out like logic, but when it comes to those specific features, I don't know. That's just gonna come with time though. But yeah, return statement. So for checking if it's not a semicolon, so we're, as long as it's not a semicolon here, we can actually set the expression to be a value. So we probably want to pass that over to the pet parser. So probably taking this value here, right, and probably saying parse expert, that function call, to call that. Should be good. And then we can okay, so that covers for that. Well, so we covered for this and we covered for this. Do we need a semicolon check after though? We probably do need a semicolon check after, so this is for, this one will use the consume. This is for token type. Also, you can't use templates directly in .c file. You should directly define and initialize them in header file, which makes compilation take a lot of time. Okay, so if we're consuming the token type for semicolon, and we also need the error message here after, so we're probably gonna say like expected semicolon after value, I guess, after expression. Or that's kind of vague. Return, let's call it return value. I think that should be good. I know about templates, but I haven't used them that much, or probably even at all. Maybe like for some practice problem or something, but I haven't used them in a project. But I know that you probably should. I know people use templates for compilers for, in some cases. For defining an implementation for multiple different types. I believe people do that. Okay, so consume, checking that value. I think we're done there, right? That covers the return statement. So essentially, yeah, then we just return as we usually do for all the things. So just return static unique to actually access. And this is going to be the ret statement, return statement. And return statement just consists of that expression, I believe. Yeah, just the red, so. So move on that expression, so that value. Not here, it should be here. There. Alright, that should work. Dang, bro, we're actually like staying consistently like over 7 people in the stream. It's actually interesting. I mean, I'd love to keep streaming, but it's actually getting late. Pretty late here, so probably gonna end it off here actually. Ooh, I hit my fan. Yeah, so I'm probably gonna end it off here. I appreciate you all for joining. We had Swan join, Online Max 12, Ghost has been here from the beginning, AJ Brady from before, and a couple other people. But yeah, I guess we're gonna end off the stream today. I appreciate you all for joining.